we've learned that when an object is in equilibrium, the forces all balance. These are the equations we use for equilibrium, and this is described by Newton's first law. Let's turn our attention to problems where that's not true. Here's a problem where the object is accelerating. What equation do we use? Newton's second law is the one that deals with acceleration. So in this problem, we have two blocks connected by a string. It's a game of tug-of-war. Which one wins? The bigger block. So the bigger block accelerates downward, and the smaller block accelerates upward. Let's draw the forces. Gravity pulls on each, and let's assume G is 10. Multiplying m times g gives us a gravity force of 60 newtons here, and here we have a gravity force of 180. Each block is touching something else, the string. So this string exerts a force called tension. We know that normally the string is not quite this stretched out. And because the end right here of the string is stretched, it wants to go back to where it was before. This end similarly has been stretched out, so the string, like a rubber band, pulls it up back toward its normal relaxed length. Which forces are positive and which ones are negative? Normally we say up is positive and down is negative, but that creates a problem. Look at the acceleration of the 18 kilograms. It would be negative because it's down, but this acceleration would be positive because it's up. We can't have two different accelerations for the blocks because they're connected by a string. The accelerations for the two have to be exactly the same, right? Okay, so we can't use up as positive and down as negative. What do we use instead? We are going to say that the direction of motion is positive and opposite that is negative. The direction of motion, okay, the 6 kilograms goes up. That's positive. The string loops around and moves this way. That's positive. This guy goes down. That's still positive. It's like we're saying that clockwise is the positive direction and counterclockwise is the negative. So which forces are positive? Which ones are with the motion? This tension and this 180. Which forces are opposite that? Which are negative? This 60 is against the motion, and so is this tension. Now that we've drawn our forces, we can apply Newton's second law. Net force equals mass times acceleration. The net force is something we have to analyze one block at a time. So let's turn our attention to this block. What's the net force on that block? Well, to find the net force, we just add up the two forces that are acting. I've got tension, which is positive, 60, which is negative. The mass of that block is 6.0, and its acceleration is just a. Then I turn my attention to the other block. I take the net force, just like before. Okay, there are two forces acting. The net is just the sum of the forces. So I've got tension, which is negative because it's opposite the motion. And I've got 180, which is positive. That block's mass is 18. And its acceleration is the same a as the other block. We have two equations and two unknowns. How do we solve? We use our tricks like substitution, elimination. I like to use elimination. If I add the left sides and add the right sides, well, on the right, 6a plus 18a, that gives me 24a. When I add these all together, I have t minus 60, a negative t, and a positive 180. Look what happens. The positive t and the negative t cancel out. And I'm left with negative 60 and 180. That's 120. If we divide by 24, 12 over 24, that's 0.5. We've got an extra power of 10, so this is going to be 5 meters per second squared. And I should make it 2 sig figs. After finding acceleration, we're halfway there. Next, let's find tension. We find the tension by taking the A value and plugging it back into one of the other equations. Let's do that. T is unknown. I've got minus 60. A is 5. We add 60 to both sides. We've got 30 here, another 60. Whoa. That gives 90, but we want 2 sig figs, so we put a decimal point. That's how we solve Atwood's machine problems. Thanks for watching.